Hello, this is topic 10-2 on scatter plots and lines of best fit. Now, real-world data doesn't always fit in a nice straight line, so what we use are scatter plots. Okay, scatter plots. And so, let's go ahead and make a scatter plot. We have a football team, they have games, and they have how many yards they get. So I've already pre-written my numbers here. You may want to pause the video and write these numbers yourself. But I'm going to go ahead and start plotting here. For game 1, we made 348 yards. So I'll come over here to game 1, 340, 360, 348 is going to be somewhere around there. Game 2, we made 350. Really close. Game 3, we only made 300. Big drop in yardage. Game 4, we only did 295. Small drop. Game 5, we did 280. Well, that one fits right at the intersection. Game 6, we did 250. It's going to be halfway between 240 and 260. In game 7, we did 225. Just a little bit above that line. Well, it looks like as the football season went on, we just made fewer and fewer yards. Obviously, the other teams were beating us more badly at the end. Maybe we were actually winning at the beginning. I don't know. This is just yards and games. We can make an analysis of that as we want. But I want to go ahead. I'll save this for later. And we want to kind of like make some predictions. Okay, we want to predict where we're going to be for game 8. Alright, so to make predictions, we need a line of best fit. Okay. A line of best fit. So to make a line of best fit, we're going to find a few points that are more or less in line. We want to draw a line through them so that the ending points kind of cluster around the line, and we're evenly distributed both above and below. And to make this even easier, I want to make sure that I hit a y-intercept that I know of. Okay? And so I'm going to call this 370, just so that I can later make an equation for my line more easily. And this line kind of sort of predicts how I'm going to score on games. Okay? And so that's a scatter plot with a line of best fit. Well, based on our lines of best fit, we have different types of correlation. Okay? We have 3 main types. We have positive, negative, and no correlation. Where positive is a trend that's going up, negative is a trend that's going down, And no correlation means I really can't tell if I'm going up or down. There doesn't seem to be a pattern. All right. Our previous example obviously had negative correlation. Well, let's take a look at another example. Here we have Old Faithful and just a little opening paragraph about it. I'm going to go ahead and jump into my points. And again, for the sake of time, I have pre-made my graph. You may want to pause so that you can do your graph on your own. This will be the length of the eruption. And this is the time till eruption. Alright, let's go ahead and do this. 2.0, I'm at 57, so wait 2 minutes. So if the eruption lasted 2 minutes, that's going to give me 57 until the next one. So I come up here, well, this is 55, 57 is going to be about halfway between 55 and 60. 2.5 is at 62, so 2.5 over here at 62. 3-minute eruption, I'm going to have to wait 68. It's going to be almost 70. A 3.5-minute eruption is going to be 75 minutes. It's actually right on the intersection. That's nice. 4.0, that's going to be 83. Just a little bit above 80. 4.5 will be 89. So almost 90. And 5.0 will be 92. And so I have my line. Now I'm going to do an equation of best fit. And there we have it. There's my line of best fit. Okay. Now, let's go ahead and see what we can do. What type of correlation do we have? Well, it's going up. It's definitely going up, so this would be positive correlation. Our independent variable, that's the one that comes first. That's our x variable. And so that would be the length of the eruption. Which means that our dependent is the time until next eruption. And now I need 2 points from my line of best fit. I'm going to go ahead and take this one, the 3.575. And let's go ahead and take this one at the 2. That was 2.57. Okay. Your line of best fit may possibly go through some different points. So from this point on, the answers may not be exactly the same. I'm going to use my 2 points to find my slope. So 75 minus 57, that's my change in y. And then I need my change in x. That would be 3.5 minus 2. $75 minus 57 is 18. And 3.5 minus 2 is 1.5. Which is 12. So my slope here is 12. Now, using point slope formula, I need to find the equation of my line. I'm going to use that point simply because it's a little bit easier. Y minus y1 equals m times x minus x1. So that would be y minus 57 equals 12 times x minus 2. Y minus 57 equals 12x minus 24. Add 57. Y equals negative 24 plus 57 is 12x plus 33. Now, we've gotten our equation because we found the slope and we used point slope to find the equation of our line. Now we need to predict how long if our eruption is 2.3 minutes. Well, the length of my eruption is my independent variable. It's my x variable. So I replace this x with 2.3. So y equals 12x plus 33. Y equals 12 times 2.3 plus 33, and that equals 60.6. And here, if you picked different points and got a different slope, you obviously would have found a different equation, but your answer should be close to the same one as mine. Now here, the next eruption is 70 minutes. That's my y value. So I'm going to put in 70 equals 12x plus 33, and I need to solve for x. I start by subtracting 33. And I get 37 equals 12x. Divide both sides by 12. And I get that x is approximately 3.08. So we'll call that 3.1. And again, these are estimates based off of how I drew my line of best fit and therefore how I got my equation. But I would expect that no matter how you drew your line of best fit, your answers to both of these questions should be close to mine. And that is all of 10-2. So, it's a matter of creating your scatter plot, drawing your line of best fit, finding the equation for your line of best fit, and using that equation to make predictions. Good luck on your assignment, and have a good day.